Dear all, very good morning. Today we will discuss top 10 question and answer in inequalities. And all the question is very important in any kind of examination, SSC, B.Sc, KVS and NVS as well as joint entrance examination. So now we'll start by first we'll write some recall, then we'll start the top 10 questions and answers in inequality. So now the first recall is related to arithmetic, geometric, and harmonic mean. Arithmetic, geometric, and harmonic mean. That means arithmetic mean, geometric mean, and HM harmonic mean. So let A1, A2, AN be n positive real numbers R plus set of all positive real number. Then arithmetic mean, this is given by A1 plus A2 plus AN by N. Geometric mean, GM, this will be A1 multiple A2 multiple AN to the power 1 by N. And harmonic mean, that will be HM equals to N by 1 by A1 plus 1 by A2 plus 1 by AN. Now we'll move another important recall. This is when you will take all kinds of mean, that means arithmetic mean, geometric mean, and harmonic mean. In general, the relation holds. In general, arithmetic mean always greater than equals to geometric mean, and geometric mean always greater than equals to harmonic mean. That is, if all A1, A2 up to N are positive real numbers, then we conclude A1 plus A2 plus up to N by N, this is greater than equal nth root of A1, A2 up to N, this is also greater than equal N by 1 by A1 plus 1 by A2 plus 1 by N. We need to recall this inequality. Now we'll move to another important concept. This is basically the next recall. Weighted arithmetic mean, harmonic mean, and geometric mean. Weighted arithmetic mean, weighted harmonic geometric mean, and weighted harmonic mean. Let P1, P2, P1, P2 up to Pn be n rational numbers, be n rational numbers, and A1, A2 up to N that are all positive real numbers that belongs to R plus, then weighted arithmetic mean, we denote W with bracket AM, weighted arithmetic mean, that will be A1 P1 plus A2 P2 plus AN Pn by P1 plus P2 up to Pn. What is P1, P2, Pn? Where P1 where the numbers A1, A2 up to N with associated weights P1, P2 up to Pn respectively. That means weight of A1 is P1, weight of A2 is P2, and weight of An is Pn respectively. Now the next, the geometric mean, weighted geometric mean, that will be A1 to the power P1 multiple A2 to the power P2 dot N to the power Pn whole to the power 1 by P1 plus P2 up to Pn. In similar way, the weighted harmonic mean, this will be P1 plus P2 plus Pn by P1 by A1 plus P2 by A2 plus Pn by N. Now again we need to recall one important inequality corresponding to weighted arithmetic mean, weighted geometric mean, and weighted harmonic mean. In general, we can say weighted arithmetic mean is always greater than equals to weighted geometric mean. This is also greater than equals to weighted harmonic mean. So this result holds in general. Now we can start the 10 important problem based on the inequality. The first problem is here. The problem is given in B.Sc examination. The value of question number 1, the value of 1 multiple 3 multiple 5 multiple 2 minus 1 is option A equals to n factorial, option B greater than n factorial, option C greater than n to the power n, and option D less than n to the power n. Less than n to the power n. So now the question is how we will solve this problem. So here we just apply how to solve. We just take the number a1, a2, n like this. a1 equals to 1, a2 equals to 3, a3 equals to 5, and n equals to 2n minus 1. And we apply arithmetic mean, applying arithmetic mean greater than equals to geometric mean, and hence we have a1 plus a2 plus n, that means 1 plus 3 plus 5 plus 2n minus 1 by n. This is arithmetic mean. This is greater than equals to nth root of 1, 3, 5, 2n minus 1 to the power 1 by n. So here you just see all are positive real numbers, so we can apply the result. Arithmetic mean greater than equals to geometric mean. So this will be the sum of n numbers which are in geometric arithmetic progression, and the common difference is basically 2. So n by 2, the sum is n by 2, the first term plus last term, 2n minus 1 by n to the power n. This is greater than equals to 1 multiple 3 multiple 5 multiple 2n minus 1. So from this we can write n to the power n. This is strictly greater than, not strictly, greater than equal 1 multiple 3 multiple 5 multiple 2n minus 1. So obviously here we just see this value less than equal, less than n to the power. Okay, here this inequality will be strictly greater than, this will be because equality holds when 1 a to n are all basically same. So this is strictly inequality. So obviously here option D is correct. Option D is correct and all other options are false. So option D is correct. And this question is exactly given in B.Sc examination 2017. Similarly, in similar way, another kind of question. The question is basically the value of 1 factorial, 3 factorial, 5 factorial, multiple 2n minus 1 factorial is option A equals to n factorial, option B greater than n factorial, option C greater than n factorial to the power n, and option D less than n factorial to the power n. Now the thing is how we will solve this kind of problem. Here I will give you a hints how to solve it. Hints. Here you just use that kind of inequality. The inequality is like this: r factorial 2n minus r factorial. This is always greater than n factorial whole square. We just apply this important result for all r equals to 1 to up to 2n. So when you just apply this result, we just putting r equals to 1, 3, 5 up to 2n minus 1 and multiplying we get the result 1 factorial, 3 factorial, 5 factorial, multiple 2n minus 1 factorial. This is strictly greater than n factorial to the power n. So obviously here option C is correct. All other options are false. So this is also another important question which has been asked in different examinations. Now we'll move another important question. Question number 3. This is exactly asked in the previous year SS examination. This is WBSSC 2016. What was the question paper? The question paper is, if n greater than equals to 2, then the value of 1 plus half plus 1/3 plus 1 by n, this value is option A, less than equals to root under 2n minus 3. Option B, greater than 2n by n plus 1. Option C, greater than 2n. Option D, less than 2n by n plus 1. Now the question is how to solve this kind of question paper. So just simply apply arithmetic mean greater than equals to harmonic mean here. The solution here you will take a1 equals to 1, a2 equals to 2 and n equals to n. All are basically positive real numbers. So by applying arithmetic mean greater than, all are unequal, so greater than geometric mean, we get a1 plus a2, that means 1 plus 2 up to n by n, this value greater than n by. Why we use the strictly inequality sign? Because all real numbers are unequal. So n by 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by n. And from this we just calculate, you will get here the left side n into n plus 1 by 2n. This value greater than n by 1 plus half plus 1/3 up to 1 by n. And from this you will see 1 plus half plus 1 by n. This value strictly greater than 2n by n plus 1. So it is strictly greater than 2n by n plus 1. So hence we can conclude option B is correct and all other options are false. Now we'll move another question, question number 4. This question also given in WBSSC examination 2016. The question is, for any positive numbers, for any two positive numbers, for any two positive real number, positive numbers, a and x, least value of x plus a by x is option A square, option B root 2 square, option C a, and option D is 2a. So now we will just think which option will be correct. So again we just these two numbers x and a by x. So we just take a1 equals to x and a2 equals to a by x, and based on these two numbers we will apply arithmetic mean greater than geometric mean, because these two numbers are unequal. So applying m greater than gm, what we will get? We will get x plus a by x by 2. This number greater than x multiple a by x whole to the power half. So obviously here we can write x plus a by x, this number strictly greater than 2a. So option D is correct. That means the least value, therefore the least value of x plus a by x is 2a, and all other options are false. So these are very important questions, because you just seen here all the questions has been given in different examination. Now we'll move another important question, and this question is given in different examination. The question is question number 5. If A, B, C all are positive real numbers, and A plus B plus C, that value is 1, then the greatest value of 1 minus A into 1 minus B into 1 minus C is option A 8 by 27, option B 1 by 27, option C 2 by 27, and option D 5 by 27. In the same question, they can ask the least value of 1 minus A, 1 minus B, and 1 minus C. So now the thing is how to solve this kind of question paper. So here also we can apply m greater than gm. Solution. So just we consider the number a1 as 1 minus a, and we just consider a2 as 1 minus b, and a3 as 1 minus c. Now the thing is, you just apply here m greater than gm. All numbers are basically, if you consider they are not equal, so you just apply this inequality. What you will get? You will get 1 minus a plus 1 minus b plus 1 minus c by 3. This is strictly greater than 1 minus a multiple 1 minus b 1 minus c whole to the power 1/3. So the value is basically here 3 minus a plus b plus c. Just you will do the simple calculation, and the power to the power q. This is greater than 1 minus a, 1 minus b, 1 minus c. So from this we just put the value of a plus b plus c 1. This is exactly given here. So 3 minus 1 by 3 whole cube. This is greater than 1 minus a, 1 minus b into 1 minus c. So it is given in question paper a plus b plus c. This is equals to 1. So from this we can conclude the greatest value of 1 minus a into 1 minus b into 1 minus c is 2 by 3 whole cube. That means 8 by 27. So this value is basically 8 by 27. So this is the correct option. All other options are false. So this question is exactly one of the important questions in any kind of examination. This question can be asked in that way. I just write the question paper in different examination, B.Sc and joint entrance or BMath. If x, y, z all are positive real number, and x plus y plus z all sums are basically 1. So then prove that 8xyz, this is less than equal 1 minus x, 1 minus y, 1 minus z, less than equal 8 by 27. That means the least value is 8xyz and the highest value is 8 by 27. So now we have seen that hence we have already proved 1 minus x 1 minus y, 1 minus z, this value less than equals to 8 by 27, just in previous question paper. So just we consider it as 1. For this part, the left side inequality, how we'll prove that? Here, for this part, it is given since x plus y plus z equals to 1. So from this we can write 1 minus x equals to y plus z, 1 minus y equals to z plus x, and 1 minus z equals to x plus y. And we have the inequality. Inequality is basically y plus z by 2. This is greater than equal root under yz. Just m greater than equals to gm. And similarly, z plus x by 2. This is greater than equals to root under zx. And x plus y by 2. This is also greater than equals to root under xy. Just we multiply all these inequalities. So what will happen? Y plus z into z plus x into x plus y. This is greater than equals to 8xyz. Now we will just put from start the y plus z equals to 1 minus x, z plus x equals to 1 minus y. Just we put here and we will get 1 minus x into 1 minus y into 1 minus z. This value greater than equals to 8xyz. So this is by star. So just we will give that this is 2. So from 1 and 2, what is our conclusion? Our conclusion is 8xyz less than equals to 1 minus x, 1 minus y, 1 minus z, and this is less than equals to 8 by 27. So obviously the question paper is proved here. So this is very, very important question which has asked in different examination. Now we have more important questions. The question is like this. Next question, question number 6. If A, B, C all are positive real numbers and A plus B plus C, this value is equals to 1. Then the minimum value, of A plus 1 by A whole square plus B plus 1 by B whole square plus C plus 1 by C whole square is option A 33 1/3, option B 33 2/3, option C 33 3/5, and option D 33 4/5. So these are the several options, and this question is also important for different examination. So now the thing is how to solve. For solving this question, we need to apply one important theorem, and the theorem is named as the mth power theorem. So now we just recall what is exactly the mth power theorem. This is very popular and important theorem in inequality. The mth power theorem says that if a1, a2 up to n are n positive real numbers and all ai's are not equal, maybe 2 of them or 3 of them equal, but not all, then summation ai to the power m I equals to 1 to n, that summation by n, it is greater than or less than summation ai by I equals to 1 to n by n whole to the power n. Now the question is when greater than and less than that kind of inequality holds. So this is holds according to or according as m does not or does lies between 0 and 1. So just you draw the real line here. So if the m is outside of 0 and 1, that means here or here, so on that case, the greater than inequality holds. If m belongs to 0 to 1, that means that position or that position, in that case, the less than inequality. So we just recall this kind of information, the information based on the image power theorem, and we can solve this kind of problem. This kind of problem is basically based on exactly on the image power theorem. So now how we'll solve? For solving this question, we just break the expression. So the hints is like this. Here we have given a plus 1 by a whole square plus b plus 1 by b whole square plus c plus 1 by c whole square. You just expand all this square term. So what we will get? We will get a square plus b square plus c square plus a to the power minus 2 plus b to the power minus 2 c to the power minus 2 plus 6. Now we try to apply the image power theorem here for m equals to 2 and also image power theorem here for m equals to minus 2. What we will get here? We just see all ABC are positive real numbers. So applying image power theorem for m equals to 2. M equals to 2. Applying image power theorem, it will be a square plus b square plus c square. M2, 2 is basically here. It is does not belongs to 0 to 1. So here the inequality will be strictly greater than by 3 since it does not belongs to 0, 1. So inequality this is greater than, strictly greater than a plus b plus c by 3 to the power m means 2. So now we put a plus b plus c, that value is 1. So it will be 1 by 9 since a plus b plus c equals to 1. Again we put for that part m equals to minus 2. This is also does not belongs to 0, 1. So for this case we can apply again e to the power minus 2 image power theorem for m equals to minus 2. So that quantity by 3, it is always strictly greater than a plus b plus c by 3 whole to the power minus 2. And again this value will be 9 because since a plus b plus c equals to 1. So what we have seen here, we have seen a square plus b square plus c square. This is greater than 3 and a to the power minus 2, b to the power minus c to the power minus 2, this is greater than 27. So from this we can write a square plus b square plus c square. This value is greater than 1/3 and a to the power minus 2, b to the power minus 2, c to the power minus 2. This value is greater than 27. So therefore, a plus 1 by a whole square plus b plus 1 by b whole square plus c plus 1 by c whole square, that value is greater than 1/3 plus 27 plus 6. So now this value will be 33 1/3. So 33 1/3, that means option A is correct. All other options are false. So I've said this type of question is very, very important and you will see it in different upcoming examinations like KVS, NVS, WBSSC, B.Sc. Now we'll move another important question. The question is basically asked in B.Sc examination. This question number 7. The question is the minimum value of 3x plus 2y, where x, y are positive real numbers, satisfying the condition x square y cube equals to 48 is option A 16, option B 12 by 7, option C 10, and option D 3 by 16. This question has been asked in P.Sc examination. So now the question is how to solve this kind of question. So here the solution, how to solve it. So for solving this question, we need to apply weighted arithmetic mean, geometric mean, and weighted harmonic mean sometimes. So we consider here two positive numbers. Consider two positive real numbers. What are the positive real numbers? One positive real number is 3x by 2 and another positive real number is 2y by 3 with associated weight. This is very, very important. With associated weights, basically 2 and 3 respectively. How we will consider the associated weight? Just you think the power of x and y, here power is x is 2, so associated weight will be 2, and you will divide 3x by 2. And the power of y is 3, the associated weight will take the 3, and you will divide the quantity to y by 3 also. And here you can apply the arithmetic mean greater than equals to geometric mean, and then applying weighted arithmetic mean greater than weighted geometric mean. So what will happen? The weighted arithmetic mean is basically P1 into A1, so 2 into 3x by 2, P2 into A2, that means 3 into 2y by 3, by P1 plus P2, that means 2 plus 3. This is greater than equal 3x by 2 whole square multiple 2y by 3 a whole cube, that means 1, and a2 to the power p2 whole to the power 1 by p1 plus p2. So we just simplify this inequality. What will happen? It will happen 3x plus 2y, that value will be greater than equals to 10. Why? Because since here x square and y cube, this value is 48. X square y cube, this value is 48. So therefore the least value or the minimum value of 2x plus 3y, 3x plus 2y, here 3x 2 cancel, 3 cancel, so 3x plus 2y, this minimum value of 3x plus 2y is 10. So option C is correct, all other options are false. So again, this kind of question is very, very important. and it is also important for different examination. Now the question is another important question. The question number 8. Question number 8. This question is also very important. If x square plus y square, if x square plus y square plus z square, this is equals to 3, then the least value of 1 by x square plus 1 by y square plus 1 by z square is option A 3, option B 9, option C 1, and option D 6. So now the question is how to solve this type of question paper. Here it is given only x square plus y square plus z square equals to 3. Just simply apply m greater than equals to hm. M greater than equals to hm. So by applying this formula m greater than equals to hm, we can write x square plus y square plus z square by 3. This is strictly greater than 3 by 1 by x square plus 1 by y square plus 1 by z. You can write the greater than equal if all x, y, z are basically same. So this is greater than equal. Equality sign hold if x, y, z are basically same. So just to put the value x square plus y square plus z square equals to 3, you will get the result 1 by x square plus 1 by y square plus 1 by z square. This value greater than equal 3. So that means therefore the minimum value or the least value of 1 by x square plus 1 by y square plus 1 by z square, this least value is basically 3. So option A is correct, all other options are false. Now we'll move to another important question. The question is asked in different examination, and the question is basically next question number 9. So question number 9, it is if n is positive integer, then prove that 1 by root under 4n plus 1, this is less than 3 into 7 into 11 dot dot 4n minus 1 by 5 into 9 into 13 into 4n plus 1. So this is less than 3 by 4n plus 3, that square root. So how we'll solve this kind of question? Solution: let r be a positive integer, then we know 4r plus 1, we just consider two number, one number is 4r plus 1 and another number is 4r minus 3 by 2, this value greater than equal. Just we apply arithmetic mean greater than equal to geometric mean. So 4r plus 1, it will strictly greater than because two numbers are basically unequal. So multiple 4r minus 3. So just you will calculate it, the simplification. So 4r minus 1, this value strictly greater than 4r plus 1 multiple 4r minus 1 square root. So that means here 4r minus 1 by 4r plus 1, that value strictly greater than 4r, this will be 4r minus 3 by 4r plus 1. Just you put or you will this time taking r equals to 1, 2 and 3 up to n and multiplying. We get, just first you put r equals to 1 here, then r equals to 2. What will get? 3 by 5 multiple 7 by 9, 11 by 13 up to 4n minus 1 by 4n plus 1. That value will be strictly greater than 1 by root under 4n plus 1. So this is single star. Again, we can write again for any positive integer r, just we consider r is a positive integer, and we have 4r minus 1 plus 4r plus 3 by 2. This is strictly greater than root under 4r minus 1 into 4r plus 3. So here we can write 4r plus 1 by 4r minus 1. This value greater than 4r plus 3 by 4r minus 1. Again, we are taking here, taking r equals to 1, 2, 3 up to n and multiplying. We have 5 by 3, 9 by 7, 4n plus 1 by 4n minus 1. This quantity is greater than 4n plus 3 by 3 square root. So that means we can write here 3 into 7 into 11 up to 4n minus 1 by 5 into 9 into 13 up to 4n plus 1. This value less than 3 by 4n plus 3, that's square root. So this is double star. So from star and double star, what we can conclude? We can conclude from star and double star. Our conclusion is 1 by root under 4n plus 1 less than 3 into 7 into 11 up to 4n minus 1 by 5 multiple 9 multiple 13 up to 4n plus 1. This value less than 3 by 4n plus 3, that is square root. So here we have proved the given question. And this question is very, very important in any kind of examination. Now we'll move to another important question. This is question number 9. The last question, question number 10. And this question has been asked in different examination. What is the question paper? The question paper is the greatest value of a square BQ, where A, B are positive real numbers, where A, B are positive real numbers, satisfying A plus B equals to 10 is option A 3, 4, 5, 6, option B 4, 3, 5, 6, option C 5, 4, 3, 6, and option D 6, 5, 4, 3. So now the question is how we'll solve. I will solve this kind of question by using the weighted arithmetic mean, weighted geometric mean, and weighted harmonic mean relation. So here we use the formula weighted arithmetic mean. This is greater than equal weighted geometric mean. And we consider two positive numbers. Consider two positive real numbers. One number is basically a by 2. A by 2, the power will be the weight a by 2, and another number is b by 3 with associated weights. Associated weights. I already said the power will be the weights 2 and 3 respectively. Okay. And now we applying weighted arithmetic mean. This is greater than equals to weighted geometric mean. We get, or we have, 2 into a by 2 plus 3 into b by 3 by 2 plus 3. This is greater than equals to a by 2l whole square b by 3l whole cube to the power 1 by 2 plus 3. And equality occurs. Here equality occurs if a by 2 equals to b by 3. So now this will be 10 by 5 whole to the power 5. This is greater than equals to a square b cube by 108. And this implies a square b cube less than equals to 3, 4, 5, 6. Just it is a simple calculation. So here we have seen the greatest value is basically 3, 4, 5, 6. So option A is correct. All other options are false. Thank you so much. And please, all of you, subscribe to my channel so that you can reach to my videos as quick as possible. Thank you so much.